Hi, this is example 2 from section 7-3, or it's kind of our third topic, our third lesson in the statistics section. All right, so let's take a moment and just go through the problem, okay? And let's read it real quick. So a police officer measures the speeds in miles per hour and collects some data on 30 motorists. So there's 30 numbers over here. And the results are shown in this table. Display the data in a histogram. Okay, so a histogram, like we saw in that last one, it kind of looks like a bar graph. We're going to try to get the spread of all the numbers and see how spread out are they overall, like this. All right. And so that's the idea. Before we can do this, we need to organize our numbers better. These are sporadic. These are kind of all over the place. So before we do that, it says begin with an interval that looks like this, which is nice. But what we need to do is create a frequency table. Okay, frequency table. And the way I would organize that is I would just make a table, but and we could do it kind of like this, and it'll have two columns in it. The first column will have the interval, kind of the range, and it says to start from 31 to 35. Now, how many numbers will that span? It'll go by fives, all right? And then right here, I want to represent the frequency. So, and remember, frequency just means how many numbers, how many people that we're driving in that range right there. And so the next span will go 36 to 40. And you can see I'm kind of going by fives. And so every 5 miles per hour, and the next one will be 41 to 45. And let's see how many intervals. Maximum, I think, is somewhere around 60. So that's the top end of our speed. And so keep going, and we're going to count them up and try to make sure we account for all of them. And so the next one is 46 to 50, and the next one after that is 51 to 55. And then after that, we got 56 to 60, and that should be our top end of our speed. So I got this table going, and I'm going to count them up, all right? And so let's go ahead and try to cross them off as I go a little bit. Okay, so in this first one, 31 to 35. There's one right there. 31 to 35. Nope. It doesn't look like very many people are going slow. So it has to be 35 or less. Nope, just one. That's all we have. So we're going to just do here. I guess we'll use yellow. That's a 1. So then I'll mark them off by color, so I know what I'm doing here, or you can see more clearly. I would just kind of cross them off if this problem was in front of me. So we're going to go 36 to 40 now, and so let's go ahead and try to find all those. 36 to 40, so less than 40, less than 40, less. Oh, there's one right there. 30. Wait, hold on. No. Not that one. Okay. Apparently, I need to figure out what's 36 to 40. All right. Hey, there's one right there. 40. 36 to 40. There's one. 36 to 40. 36 to... right there. There's another one. Okay. Did I get them all? I know. Kind of a searching game to figure out if you got them all or not. But there's 3. And at the end, maybe you'll find one that you missed and then add it back into the tally mark. All right. So then our next range is 41 to 45. Okay. We'll use that color, 41 to 45. So let's see if I can get all these ones. 41 to 45. There's a 45. 41 to 45 right there. 41 to 45. 41. It's got to be less than 45 then. And it looks like, how many do I have there? 3 so far. I know you're probably seeing a ton of them, and I'm not getting them. This is the fun part. Nope, not less than 45. Did I get them all? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, that looks like all of them, I think. Yep. So we got a count of 5. All right. And right here we got 46 to 50. Okay, so let's do that one. 46 to 50 is more kind of in the middle of our data, so you could kind of expect maybe there's a little bit more in that area there. Okay, so 46 to 50. So less than 50. Wait, hold on. Let's pick this color. So that 50 is in the red. Okay, there's another 50. There's another 50. Hey, there's 49 and 48. All right. I think 1, 2, 3, 4, 5 of them. Okay. Oh, wait, there's a 47. So there should be 6 of them then. Because make sure we got them all. Okay. 6 right there. Good. 51 to 55. All right, let's do green. 51 to 55. Less than 55 then. All right, 55 or less. There's a bunch of those. All right. 55. Less than 55. 51 to 55. A ton of them. Okay, did I get them all? Oh, there's another 55. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so we've got a count of 11 there. So 56 to 60 now. This is our last one. So it looks like everything that's left, hopefully. So 56 to 60. 1, 2, 3, and 4. Okay, you can see that's kind of time consuming, especially for 30 motorists. I'm not sure we would give you one that had that many data points in it. Although that's kind of the point when it comes to histograms, because we want you to be able to represent a lot of data with a histogram. It doesn't make sense to use a histogram really unless there's a lot of values to represent. Okay, so the next thing is to actually make your histogram now. Okay, so the histogram is kind of like a bar graph a little bit, but it's got an X and a Y. And remember down here is speeds. And then right here we would say frequency on this side. And so I'm just going to abbreviate frequency. Okay, so what's my highest frequency? My highest frequency looks like this one right here, which is 11. All right, and my lowest is 1. So I want to get it all the way up here to 11. All right, which means I'll have to kind of start my spacing a little bit small. And what I could do is I could start right like that and go like, say, maybe call that 2, because I don't have to go by ones. To go by ones, I would have to be marking a lot of them. So instead, maybe I'll go by 2, 4, 6, 8, 10, 12. Wait, maybe I go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10, 11. Oh, that'll be nice. All right. So I could only write down like 2, 4, 6, 8, 10, and then, 11 all the way up there. But I have to go by regular repeating amounts. I can't just jump to to 50 up here or whatever. It has to go by the same increment and space them consistently. Okay, so I'm going to go and I'm going to make my bars. You notice that I offset it at the beginning here just a little bit. That's okay. You can kind of bump it out. And my interval, the first interval is 31 to 35. The second interval looks like this, and the third interval, and the fourth interval, and the fifth interval, and the sixth interval. I think I have 6. 1, 2, 3, 4, 5, 6 intervals. All right, so this one is 36 to 40. And this one's 41 to 45. And you can see this takes a little bit of work to do it by hand, right? So this is 46 to 50, and this is 51 to 55, and this is 56 to 60 on the very end here. Okay, so let's go ahead and put on our intervals now, or our actual bars. This has a frequency of 1, so I'm going to make my 1 that looks like that. Okay, at 1 right there. So I'm going to go to 3 now, and I'm going to make a bar at 3, and hopefully it's about the same width. That's one of our rules when it comes to histograms, to make it about the same exact width to emphasize the interval that it spans across. Okay, so here I'm going to go 3 and then 5. I'm going to jump to 5. Something like that. And then we're going to go to 6. And then we're going to go to 11, all the way up to 11 here. And then we're going to go to 4. And remember, I'm just kind of working down the list here. I had to make my own frequency table, and then back down to 4. Okay. This helps us see the spread of the data. You can tell right away that it's a little bit high. It's not necessarily symmetric because it doesn't follow a very nice bell curve necessarily. These 11 values are a little shifted higher. And so how would you interpret these results, and which measure of center is best? Okay, so the best measure of center on this one, since it's slightly skewed here, and you can see it peaks and has a sharp end to it. So you would say this is the tail, and the tail is towards the, not the right, but the left-hand side. So we say it's skewed left slightly. All right, and so that's how we would kind of interpret these results, and we would say that what's the best measure? If it's skewed left or skewed right, then the mean is not necessarily a good. If I were to estimate, I would say that the mean, X bar, would be about right there. What's the best way to summarize our data then? I would say the median. Median is always best measure of center if it is skewed in any way. All right, and so this last question says if the speed limit's 45 miles an hour. Here's the cutoff for speed limit. That means not very many people are going the speed limit. Here's our cutoff right there. And so it looks like a lot of people are going over the speed limit. Most of our data is over the speed limit. So that's interpret these results, and you would just say something like the majority of our 30 motorists are actually going over the speed limit. And so that concludes our second example.